Metals react by losing electrons. That's oxidation. The reactivity series ranks from most reactive to least. Potassium, sodium, calcium, magnesium, aluminium, carbon, zinc, iron, hydrogen, copper, silver, gold. Silver and gold are very unreactive, which is why we like to use them for jewellery. A more reactive metal will displace a less reactive one from its compound. Metals less reactive than carbon, like iron, can be extracted by reduction with carbon. Metals more reactive than carbon, like aluminium, need electrolysis instead. When asked why aluminium is extracted by electrolysis and not by carbon, the marking point is aluminium is more reactive than carbon. Always link the method to the position in the reactivity series. Reactions of metals with water and acid. Reactive metals react with water to make a metal hydroxide and hydrogen. Only potassium, sodium, lithium, calcium and magnesium react noticeably with cold water because they're quite reactive. Less reactive metals like zinc and iron need acid. A metal plus acid gives a salt plus hydrogen, and you can test for hydrogen with the squeaky pop test. Copper, silver and gold do not react with dilute acid at all because they're so unreactive. When asked what gas is produced, the answer for metal plus water and metal plus acid is the same, hydrogen, and you test it with a lit splint and listen for the squeaky pop. Acids, alkalis and pH. Acids release hydrogen ions in water. Alkalis release hydroxide ions. The pH scale runs from 0 to 14. 0 to 6 is acidic, 7 is neutral, and 8 to 14 is alkaline. Universal indicator gives a colour for every pH. Red for strong acids, green for neutral, and purple for strong alkalis. When an acid and an alkali react, the hydrogen ion and the hydroxide ion combine to make water, and that is neutralization. An examiner tip: the ionic equation for neutralization is always the same. H plus OH minus gives H2O. Reactions of acids. There are 3 classic reactions of acids to know. Acid plus a metal makes a salt plus hydrogen. Acid plus a base, which can be a metal oxide or hydroxide, makes a salt plus water. And acid plus a carbonate makes a salt plus water plus carbon dioxide. The name of the salt comes from the acid. Hydrochloric acid makes chlorides, sulfuric acid makes sulfates, and nitric acid makes nitrates. Examiner tip: the carbonate reaction is the one that most students forget the extra product on. Acid plus carbonate makes a salt plus water plus carbon dioxide. 3 products, not 2. Metal makes hydrogen, base makes water, carbonate adds carbon dioxide. Each reactant brings its own extra product. Required practical: making a soluble salt. To make a soluble salt, you react an acid with an excess of an insoluble base. Warm the acid gently, add the base until no more dissolves, then filter to remove the excess. Heat the filtrate to evaporate some water, then leave it to crystallize. The crystals that form are your salt. Excess base means all the acid has reacted, so the salt is pure. In an exam, when asked why you use excess base, the marking point is to make sure all the acid has reacted. Filtering removes the leftover base, leaving the salt in solution. Electrolysis of molten compounds. Electrolysis splits an ionic compound, either molten or dissolved in water, and uses electricity. Positive ions move to the cathode, which is the negative electrode, and gain electrons. Sorry, cat lovers, but sometimes cats can be a bit negative, and that's how I remember that the negative electrode is called the cathode. Negative ions move to the anode. The anode is the positive electrode, and there they lose electrons, and that's oxidation. Oxidation is loss. Oil rig. Oxidation is loss, reduction is gain. Electrolysis is how aluminium is extracted from aluminium oxide. Examiner tip: the most common mistake is mixing up cathode and anode. The cathode is negative and positive ions are attracted to it. Opposite charges attract every time. Electrolysis of aqueous solutions. Aqueous means dissolved in water, so there are extra ions floating around. Hydrogen ions and hydroxide ions from the water itself. At the cathode, you get positive hydrogen, unless the metal ion is less reactive than hydrogen, in which case the metal forms. At the anode, you get the halogen if a halide is present, otherwise you get oxygen. Examiner tip: 2 rules to memorize. Cathode produces hydrogen unless the metal is below hydrogen in reactivity. The anode produces a halogen if one is there, otherwise you get oxygen. So less reactive than hydrogen, metal wins. If a halide is present, halogen wins. Required practical: electrolysis of copper sulfate. In this practical, you electrolyze copper sulfate solution using inert carbon electrodes. Copper ions move to the cathode and form a coating of copper metal there. At the anode, you get oxygen because sulfate stays in solution. Weigh the electrodes before and after to measure the mass change. If the electrodes are copper instead of carbon, the result changes. The anode disappears and copper transfers across, and that's how copper is purified industrially. Carbon stays, copper moves, oxygen escapes. 3 things happen, one at each spot in the cell.